Welcome again. In the last episode, what we have done is to fix some memory bugs. And here again, we encounter another segfault. In this case, it has to do with trying to write values into the chunk. Before moving a bit further, let's take a look at what the error actually means. And trace a bit of the pointers to see what we are actually messing up. So the error here is in the add constant. Looking at the code for add constant in chunk 62. We have a write value array. And this write value array doesn't resize the array beforehand. Let's take a look at all the write value array function. We have one in chunk.c, value.h, value.c, those are definitions. We have some in the compiler as well. I think we updated write value array. We updated those to resize before writing. And vm.c, we resize before writing. I guess what's left is chunk.c, where we didn't really do the resize. So it's a bit wonky here. In what sense? This chunk is a pointer, and write value array basically has to resize the pointer first. Let's look at where this add constant is being called. Is it the only case of write value array? This is. And this constant is being called in compiler.c. Add constant. And this is the only function called in make constant. And it looks like we actually do resize it on the outside. Maybe this is a bit too wonky. Let's make the actual size increase in this call itself. Because emit also calls make constant. emit constant, make constant. Okay. So before I add my constant, I'm going to resize the array. And resizing the array here, make sure that when we try to put something into value array here, we don't need to actually add any values to resize it. We don't need to add capacity to resize it. Building it. Let's try running the test files. Okay, segfault. It's the same error. Also in add constant. Let's print some stuff here. Okay, let's add some stuff here. Make constant cause add constant, which cause write value array. Okay, let's check value array. Current chunk C7. So this is the correct pointer. Value arrays. Let's check. This is strange. They are not resized correctly. Why is it that this is capacity 8 but has value 0? To find out, we'll watch. Let's try to print this thing first to see what it returns. This returns a chunk, and we want to watch the constants. Values. Okay, I'm gonna watch this. Let me run my test again. This is weird. Let me try running it again. Right, segfault. No one actually wrote it. No one actually changed the value. So that's strange. Right, let's watch some other value. Full break. Oh, I never set it. So I need to set a breakpoint. Where do I set my breakpoint? I want to do current chunk constants values. And I want to watch this. So watching this value, I run my test again. There's a segfault. Okay, how about it could because it's 0. Let's watch. Let's do a breakpoint on add constant. Run my test. Then after that, do my watching. There is some error going on here. This isn't expected. Why is this the case? Okay, let's kill it. Okay, how can we debug this then? Let's be a bit less lazy and actually go through all the core of add chunk. Let's run the test once. Add chunk. Okay. That's the error. Okay. Or add constant. Breakpoint on add constant. Run my test again. Okay, so let's take a look at my length. I'm pointing the right thing here. Now count of 0. This is weird. Why would these values now be 0? Is it still pointing to the same thing? There's a swap. Okay, I have a constant, the values is 0, and then it segfaults out, which is expected. So how do we fix this? Let's take a look at what the functions are called. So my constant my chunk is actually A58. I run it, A58, and this is correct, at least in now. A58 pointing to values with count 1. Add constant is ran again, but now it's capacity 8, 0, and it's a different chunk altogether. So what's going on here? So the chunk is definitely in managed memory territory because of the 555 prefix. So how do you figure out what's going on here? The problem is the problem here is with the count being updated. This is a new chunk, therefore we haven't allocated any values to it yet. Let's take a look at init chunk to see whether we actually initted it correctly. In chunk.c, we'll have an init chunk. And what we do is we just do an init value array. Let's take a look at init value array. It might be that the init value array gone wrong. So looking at value.c, init value array. Okay, when I resize value array, I want the value to grow array. Okay, in grow array actually points correctly. Okay, let's put a breakpoint on resize value array then to check out what it's actually pointing to. Break point on resize value array. Okay, let's run the whole test again. 25 closure. Resize value array, and this is from define native. Okay, define value array. This is called in define native. Again, okay. Like no. Backtrace. How come I keep resizing? Yes, I call resize every time. Okay, backtrace, resize. Okay. Okay, add constant. This is the first time I try to add constant. And in add constant, I resize value array. This can be seen from my check here. Okay. So at this point, what I have is let's print my current chunk. Oh. Print current chunk. Okay, so I have something here. Right, it's okay. It's the second one that is a bit error. A token string resize array. Okay. Token string resize array again. Make constant resize array. Okay. When I do emit constant, I do make constant and resize my array. When I print the constants here, it's okay. Okay. Right. I might have a resize. Let's check. Okay, still correct. After writing, I'll have one new count in my chunk constant. This is all expected. And I'll have a string token. Okay. Okay, now it's capacity 0. Alright, let's watch the capacity to see when it grows. Current chunk capacity. Okay. Maybe watching current chunk is a bit much. Okay, maybe watching current chunk is a bit much. Okay, going down the previous route. I'm going to just breakpoint add constant first and see how it goes. Add constant, I print current chunk constant. It's correct. Constant, correct. Add constants, error. Okay, this is weird. Okay, let's look at add constant. Definition of add. No, the definition of current chunk. Current function chunk. This compiler is a bit wonky, apparently. Right. This is managed memory. This is managed memory. For instance, this is managed memory capacity. Let's try watching this to see whether it actually dies. Now rerun our test. Okay. That's not right. Print. Oh, I don't have this thingy yet. Okay, I don't have this thingy yet. Okay, so init compiler. Let's look at the. Okay, so init compiler. We basically try to watch this, and this kind of fit on us. So let's try. init compiler in 174. Let's take a look. If it's chunk. Right, a new function. If I print it now, it will just show 0, which is correct. Right, I resize it. Backtrace, it make constant, right? Actually resize it, it make constant. Compiler compiler 267. I print it, but then it doesn't do much. It didn't actually do it correctly. Value.c19. Let's check it out. Okay, wait. Value.c19 first. Let's go. So I changed my capacity. All right. Now it's on grow array. So let's type in the function to see what happens. I'm like, okay, I call, my pointer is new, I'm 0, I'm 1. Okay. I find something. I move. There's a compact move going on here. So I continue. Then I mark compiler roots. At this point of time, it's still value 0. I haven't done my resizing. It's still in resizing. Marks everything. But at the end of the day, my value is still 0. So what's going on here? So grow array. I should have shifted. Let's expand this out for a while here. Okay. I put this into array. Then I set array dot values to type value star will locate array values. Oh, it could be wrong. Okay, but it's new now, so it's okay. Type of value count 0. Okay. Type of value count array dot capacity. Okay. This is value star new var new array equals to maybe this is the key. Oh yeah, maybe that's a key here. Maybe my okay, whatever. Let's prove that I'm wrong first. Okay, let me see. Okay, then after that I get my array back from temp source. Then after that set the value to new array. This should be correct. Okay. Build, run test, and if everything works, it should close with another error. Nice. So it looks like we indeed have another error with our grow array. Okay, so what's wrong here? And what should the correct code be? So in this case, what we observe is that when we are doing resize value array, we allocated new memory for the value array, but it's not being written to the new address. This is bug in grow array. Okay, so how do we fix this? We fix this by actually allocating something new here. And then allocating it, then doing okay. So this should be the new definition of the macro. Okay, let's try it. Run my test. Okay. Test 25 closure.logs. No, let's check. There's a lot more errors now. Pointer. Oh, it might not be a value array. Let's do a. No, it's not always a value array. Void star. Yeah, let's do this. Oh, new value. New R. New value undeclared. New R. Oh, in memory there's also new R. Okay. Grow R. Okay, let's do it. Grow R. Okay, that's wrong. Okay, how do we point that? Okay, I guess we need to have a grow R. Then we need to have this in memory somewhere. When also I have a external void star grow R, and I actually define it in my memory.c. It's annoying. Okay, grow array, grow array, grow array. Okay, let's try building it. Okay, looks about right. Running in GDB. Test 25. Closure, yes. Okay, now I get another error. And the reason is because right now, this particular one should be a compiler error. I suspect. But how can I check this? Right now, let's look at the opcode that's generated. To do that, let's first clean up okay, so this is all done. Right, so the fix here is to create a new variable called row R that can point to the new memory before we assign it to the pointer's new location. Okay, so here let's fix our common.h to undefine some of the loggings. Build again. Now let's run logs test 25 closure. Inner function get out value. Okay. Meet get out value. Let's check whether the functions are actually correct for the opcode at least. How do I do that? I'll do that in script. Okay, I wrote into X script. So this is the first part. Okay. Okay, this is the actual running. I have a weird definition here. Let's make sure that all the rest here are correct. As a comparison, I'll put in the code. I'll put in the test code that I have here. Inner should have A, B, C, D or up value. Add in between them, print and return new. Mid should declare C and D and declare a inner function that takes in up value 0, 1, local 1 and 2, and return this op closure. outer should have 1 and 2, have a out closure that takes in the two values for out value, return the function itself. In this case, all this op constant and define global are all wrong. By call, pop new. The error is with all these functions. The opcode is correct, but the thing that it's pointing to is definitely wrong. To make sure that I haven't made any error, let's do one other thing and try to disable disable garbage compact. Okay, let's don't run this. Okay, if I disable garbage compact and I run my test, I shouldn't have any error, hopefully. Oh, I still have error, so it's not because of memory moving. It could be. No, it's not because of memory moving, although the op constant is a bit different. Okay, let's try running again. Okay. So if I turn back on with with garbage compact turned off, I have this, and turning it back on, building it. I have this. Good. Error. So clearly we have some things that we are not shifting correctly. There are still some part of the memory, managed memory, that we are not updating correctly. And this is with respect to global variables. Maybe they're not marked, they are removed or whatever, but there's some problem here. Okay, with that, let's end off today's session with a short summary. So what have we fixed? At the start of the session, our error was basically that we are having a segfault because we are trying to read a pointer that is actually null. And the reason that is null, we found out, is because we are not actually putting in the new pointer address to the place where it's supposed to be. Instead, we are overwriting the old values after everything has been shifted. To fix that, is basically a fix in the grow array function, and that was done. Then we found another compiler error, right? This time it's not because we are generating a wrong opcode. Instead, the opcodes generated are correct, but the underlying objects that they point to don't seem to be correct. So we'll be checking that out. And with that, we will end current session. Thank you very much.